In this video, we're going to talk about dilution and the process of dilution, as well as how we can do a calculation to determine the concentration of our now diluted samples. So dilution, we talked about earlier, but it's when you're taking your sample that has more solute per volume and adding more solvent and making a dilute solution or a lower concentration. The calculation to get from your original concentration and volume to your new concentration volume is pretty simple. So here's that formula. You're going to have the concentration of your initial sample and the volume of that sample. You're going to typically know the volume that you're diluting it to, and then you can calculate the new concentration, or if you know what concentration you want, you can calculate what volume it would need to be diluted to. Really the only requirements for using this are that your units are the same on both sides. So what the concentration is or what the volume is doesn't matter as long as you know the units are the same on both sides. You also want to keep track in the problems if it's giving you final volumes. So V2 would be a final volume, or if it says you're adding this amount to the initial volume, so then you actually have to add the two together. So much like in previous problems where you were thinking about the difference between solute, solvent, and the solution volume, here you want to pay attention to whether it's just telling you this is the total or this is how much you're adding. So in this example, we want to know the molarity of the solution that we get when we dilute 35 milliliters of a 1.25 molar sample to these final volumes. So it is giving us the final volume. So I'm not going to have to add anything here. So I know my starting volume is 35 milliliters. I know my starting concentration is 1.25 molar. And for this first sample, I know my final volume is 50 liters. So notice I have liters and milliliters, so I need to do a conversion. So 50 liters is going to be times 1,000, 50,000 milliliters. So again, I could have done the 35 to liters as well. I just chose to go to milliliters, it doesn't matter. So I'm going to take the 35 milliliters. That's times the initial concentration, which is 1.25. That's equal to the new volume of 50,000 milliliters times the new concentration, which is what I'm trying to calculate. So to solve for that new concentration, I'm going to divide by 50,000 on both sides. And what you come up with for the final answer is you get 8.75 times 10 to the negative fourth. And because our original concentration was molar, our new concentration will have the same unit. See if you can calculate the second dilution concentration. All right, here's the setup for the second one. This one saves the step of conversion. I'm already in milliliters. So I have my initial volume times my initial concentration equal to the new volume times the new concentration. Solve for the new concentration and you should end up with 0.0449 molar. This example says we have half of sample 1 removed and placed into a separate container where the volume is doubled. And we want to draw what that resulting solution is going to look like. So second beaker, we're going to double our volume. So I'm going to eyeball, here's my double in volume. And remember, when you're diluting, the particles in the original sample are still in the new sample and it stays that same amount. So we've got 4, 5, 6, 7, 8, 9, 10, 11, 12 particles. So we're going to have those same 12 particles. That's 12. Just now spread out over twice as much volume. And so there's your diluted sample.